This conference will now be recorded.
So thanks everyone for attending today's SAI community meeting. Today our topic is a pull request discussing adding a bare metal Tor extension module by Marianne from Mellanox. Hi Marianne, would you like to go ahead?
Hi, yes, thank you. So I would like to start with a small disclaimer. This module is an experimental, and it won't go to standard SAI API headers. Because the reason for that is that bare metal Tor extension is auto-generated using SAI P4 Flex infrastructure. So it is generated from a P4 program using our compiler, and it is supported currently by Mellanox. For now, we decided to put it into experimental folder, but in the future, I'm working on the infrastructure to make these headers fully auto-generated and not manually put them into experimental. A few words about the purpose of this module. So we are working with Microsoft on bare metal Tor connectivity, which is basically implementation of L3 VXLAN, which means encapsulating packets into VXLAN tunnel based on the basic destination IP of the bare metal packet. So this SAI header has two types of APIs. Okay, let's start from the APIs. If you have any questions, just interrupt me. We have two types of tables or two types of APIs. The first one is called table peering entry, and second one is called table vhost entry. So first table peering entry is responsible for peering between VNets. So in a legacy implementation, this would mean a peering of routes between two different VRFs. And in case of this module, we actually have a quite different implementation, which is based on a bit vector that I will show you later. And second table is table vhost entry. This one is actually responsible for matching based on destination IP of the packets and then applying a corresponding action. The main action is actually go to tunnel that I mentioned before, which means encapsulating packets into the VXLAN tunnel. But also we support a range of different types of actions to have even more flexible and scalable implementations using, as an example, we can also use a DPDK server for greater scalability, or we can also support regular routes alongside with tunnels. So this describes two types of APIs we have, and correspondingly we have the following new types of objects, SAI objects. First one is table peering entry object, and second one is SAI object type table vhost entry that I was mentioning before, and new API type SAI API extensions. SAI API BMTOR. So this is basically all of the APIs. Also, we generate a few APIs that help us gather some statistics. We have vhost entry stats, and I'm not sure about peering entry stats. No, we don't have peering entry stats. Okay, so let's go to the attributes. First, first, um, first type of attributes is table peering entry attributes. These include basically two main attributes. First one is action, and second one is source port. So here, source port in our table is a key on which we do a match. So based on the source port, we assign a packet to a specific vhost, or in legacy terminology to a VRF. Uh, Sorry, VNet, or in legacy terminology to VRF, and the action for that packet will be one of defined actions of SAI table peering action, which is only one action that is set VNet bitmap, or no action if there is a case for that. But basically, this means that we mark in a metadata to which VNet or to which VRF this package belongs. And we need this later to do a match on in a second table on this VNet to see if we can later pass this packet and encapsulate it to tunnel or not. So first table is pretty straightforward. It's based on the source port. It marks a packet with the corresponding VNet. Second table is called vhost entry action, which is basically a table that contains all the vhost routes. So vhost routes can be of a few different types. So main type here is a action go to tunnel. So if we get a packet with with a destination IP that matches our entry, we can apply the most common action is go to tunnel, but also we support a few different kinds of actions. So we support action to router. So in this case, a packet that came in won't be encapsulated into VXLAN. It will just go to router and will be routed as a regular packet. It's kind of same handling as standard routing table. And also we support action to port. This action is quite specific. It means that if we get a packet, and for example, we can the way we use it is we set action to port as a default action for the case where we have a DPDK server running the same type of encapsulation along with our switch to increase capacity. So we can, by default, forward all packets to DPDK port and use our switch only to a subset of elephant flows that will be forwarded and encapsulated by the switch. Maybe someone has any questions by now? Yes, I can hear someone.
Sorry, I was just going to ask, is there a document that, kind of explains this a little bit better in terms of flows and those kind of things?
Yes. So there is a VXLAN VRF design document. It is submitted by Prince from Microsoft, but it only describes a subset of functionality that is supported by this SAI module. Basically, it describes the main functionality, which is related to VXLANs. But as I said, we also support a few different actions. But if you want to refer to main concept of VXLAN encapsulation for bare metal Tor, you can refer to that document. I will include it later in the comments in this chat. Okay, so let's go over the rest of the attributes for the vhost entry. Action is the one that I described just now. Also, we have priority to prioritize all these rules. And besides action, we also need attributes for match. And match is done on metadata, which is set in the first by the first table. So we do a match by the VNet and also by the destination IP. So these are two main keys for doing a match, and action is the one that we specify. It's either go to tunnel or go to port or go to router. So there's also attribute as default. So as I said, we can use, for example, we can add entry which is go to port on any match that we have as a default action, and otherwise we can just live without a default action. Also, we have necessary attributes that may change according to the action that we choose. So, for example, if our action is go to tunnel, we need to specify bridge ID and tunnel ID for that action. So beforehand, we need to create those bridge and tunnel.
For the default, do we mean a mask of 0 and 0 IP, basically?
Yeah, you are right. So this will match everything and forward packets to a port, for example, to another port to be handled by the PDK host.
Okay, so this is always the default is a complete matcher. I mean, it means mask 0 and there is no like partial default rule where I can say, partial mask and without IP.
Okay. I think for now, no. So it's like in P4, you specify default action, which will be executed if any of the key matches existing entries.
Okay.
Sure. I noticed that the peer entry meta range that was bitmap, right?
Yes,
so
it is.
It's only U16. It means you can only peer in with 16 other peers, if I understand correctly.
Currently, yes. This is extendable, but in current implementation, yes, it is 16 for now. VNets, 16 VNets.
Okay.
You could have a list instead of a bitmap.
Sorry, again?
Yeah.
I'm saying you could have a list attribute, list data type versus bitmaps.
You mean to specify peers?
Yeah, whatever these bits represent, I mean, it's unextendable the way it is currently. So what Gohan is saying, make it extendable, use a list data type, SAI data type.
Probably yes. Yes, I'll think about it. But in that case, we would need also to change peering entry attribute as well for
Right.
the vHost entry. Okay, so other attributes that we have, as I said, if we have action go to tunnel are bridge ID, tunnel ID, and underlay destination IP that will be used for that packet. If action is go to router, then we have virtual router ID as an attribute. And if the action is go to port, attribute is SAI object ID with object type port, which specifies to which port we need to forward this packet. So basically,
is it
that's
just
it.
a port? Could it be a lag as well?
Currently, it's port.
Okay, so no lag. Okay.
I'm not sure if we support logs right now. So it's for now it's port, only port. But anyway, the idea behind forwarding to port is to forward it to the BTK port, and having 4DG port is, I think it's enough for now.
So I also noticed in your vHost entry, your IP address is not a prefix.
Yes, you are right. This is where is it? Destination IP is not the prefix. It's a bug that we didn't fix yet. It will be fixed in a compiler, so we will support LPM match. So for now, it's an exact.
So that means this attribute need to be changed to use the prefix?
Yes.
Okay. Should we change it now? Because it seems that the API should be prefix, right?
It should be prefix. I will talk to Mati, and yeah, it seems that it's quite urgent to fix this, and maybe I will update pull request quite soon with the prefix. I'll fix a compiler to support prefixes. So probably, yeah, we will decide it, I think, early next week.
So what is the match priority? I mean, on the one hand, we want the LPM match. On the other hand, we have priority also. And mask. I mean.
So okay, match in the vHost table consists of two keys. First key is metadata, which is our VNet bitmap, and second one is destination prefix or destination IP for now. So this is an actual match.
Okay.
Yeah. So then in this case, if it's LPM, so why is the priorities needed?
Or maybe the priority was in the other table, Marian, and I got confused.
You mean this priority?
Yeah, this priority. That's what I meant. Why? Yeah, if it's that got me confused because we're seeking for the longest match,
Yeah, so
I guess,
yeah,
and
basically the user can set the same priority for all the entries. It's for more flexibility, but we don't have a final decision if to actually expose priority or to keep it inside the compiler. So for now, it's exposed. If we will need it for some cases.
But what I said, I don't understand the precedence. I mean, if LPM has the higher priority or the priority field. I mean, we want to match the longest, but then I can say an opposite thing with the priority. So it's not so clear what's the precedence.
I see what you mean. So if priority is, actually, I'm not sure. It is, if we're talking about hardware, it's an ACL rule priority. So I'm not sure which will take precedence here.
Okay, so I think we need a clear explanation. If the priority is left, how it works with stronger.
Yeah, sure. We will talk. I wanted to talk about that with my team to understand if we still need to expose priorities or maybe it should be hidden. So yeah, we will talk about that as well. And if it will be exposed, then we will provide the clarification, which has higher priority.
So where do we specify the MAC address?
You mean different destination MAC?
Yeah.
It's not supported yet.
Okay.
So we cannot override destination MAC right now. But actually, we haven't discussed that when we are going to include that. So I cannot provide an answer for that when it will be supported.
Okay.
And Marian, one other comment. You have a
Yes.
statistics function in this module.
Yes.
In the new SAI format, we also have extended statistics function in every header, which gets a flag. So please just add also an extended statistics function.
The flag is to clear statistics, something like
Yeah,
that.
it has. Yeah, so each module now has the original entry
Yes,
stats,
thank you.
and extended.
Yeah, I will fix the template for headers as well. Okay, thank you.
Also, where is the destination VXLAN ID? If we need to override, how do you determine the destination of the VXLAN ID?
You mean VNI?
Yeah.
VNI. Okay, let me try to remember. So how the flow goes? We create a. So the user needs to create a map, bridge to VNI and VNI to bridge. And based on which bridge you pass here, the corresponding VNI will be set. So VNI is taken from bridge.
Where do you get the bridge?
Bridge needs to be created before creating vhost entry.
But where do you know? The packet coming from port. Then how do you know which bridge this packet enters? Because the source port, there's only metadata about the bitmap. How do I know which bridge is the packet of the packet?
Well, okay. So let's go over the flow again. So we enter the first table, which has match as a source port and action VNet set VNet bitmap, and we assign a packet to a corresponding VNet. And second, after that, the packet enters the second table, which is a vhost entry table, and it matches by. Yeah.
Why? Maybe I misunderstood. Okay. Go on. I think that. Okay. I'm. Yeah.
Next table where we have keys which are our peerings described by metadata and metadata mask, and a destination IP. And based on that, the action is actually go to tunnel or go to bridge. So based on this match, we will choose a right bridge.
No, the action is go to tunnel, right? So
it is go to tunnel. It is called go to tunnel, but actually in hardware it is go to bridge.
But which bridge? Where do you decide which bridge?
You specify the bridge ID right here.
No, but your action is your action a bitmap? You can both go to the tunnel and go to the bridge.
No, you go to the bridge, and from bridge, then the legacy pipeline is executed, and based on the bridge, you are encapsulated in a right tunnel.
So
basically, for go to tunnel, you specify a couple of parameters. You're saying you specify several objects.
Yes, you specify bridge ID, tunnel ID.
Then is your action a bitmap? I mean, is action or action list? Because action, I saw your action is only one action, right? So it seems like
this is for the first table. Action is set VNet bitmap, and for the second table, it's go to tunnel or to route or port.
So Marian, we choose just one action, which is to go to tunnel, but this action is composed of several steps and gets several parameters.
Yeah, exactly. So for go to tunnel, we need to specify bridge ID, tunnel ID, and underlay destination IP. So these three attributes are mandatory for a go to tunnel action.
Do we have that embedded in the metadata?
Why do you need it in metadata? I didn't understand. We only do a match by metadata.
No. I mean, okay. I see. So there's a condition on that. Okay.
You mean this condition?
Yeah.
Yeah.
So for each peering VNet, you will create a bridge ID. Is that the case?
Yes.
Okay.
So basically, we have like for each VNI, we have a bridge. Yeah.
So why can't we just specify? Do we really need to understand there is a bridge there? Oh, we can just specify VNI in the table entry, in the way host entry, and
you mean that bridge will be automatically created? Because we need bridge.
Okay. That's fine. I think I understand now. Yeah.
Okay. Maybe someone else has questions? Okay then. That's basically everything from my side.
Oh, sorry. So for the Weihou tree, why that is also a bitmap? Isn't that just
this one?
in the Weihou tree,
yeah, because we do a match by bitmap.
I mean, I'm trying to understand here. For the port, you get a bitmap, and then
Yes.
for Weihou tree, is it always only one bit is enabled for a particular entry, indicating which?
No. This indicates a peering. So by this attribute, we specify a peering in vhost entry, meaning with which other VNets this entry can peer.
Okay, so then why on the table it's also a bitmap? Is that
Well, this is kind of our implementation decision, but in table peering entry, this will always be only one bit enabled. So I'm not sure if we should choose another data type. So here if we're looking at peering entry table, here, yes, the attribute metadata is also a bitmap, but this will always have only one bit enabled.
So does this represent a register? What does REG mean?
Yeah, it means register. It's metadata register.
I mean, typically we would not expose register level attributes. They shouldn't show up at the SAI level, right? Unless there are other existing examples.
Probably you're right, but if we're talking about before terminology, it's basically a metadata. I'm not sure what's the right name to call it. Metadata bitmap, metadata whatever. It's like just a metadata chunk of memory that we can use. So
okay.
We are open to any suggestions.
Metadata makes it slightly more generic.
Okay, probably you're right. It can be changed.
Yeah, I mean, I'm sorry, but in general, it seems like a pretty big a spec. But since there was no presentation or documentation ahead of time, I don't completely understand it as of now. Of course, I understand it's an extension, so this probably doesn't even mean anything to others, but
yeah, right. Okay, go on. Anybody else?
So this is actually echo Tusha. If our pull request only have the API changes, it will be hard for people to understand, and also harder for people to come to this release to understand what is in this release. Can we add a description, to the to your PR about what this is about, the scenarios?
Yes.
And yeah.
Yes, for sure. I'm working on the documentation right now because we didn't have a single design document for all the plan projects before. So I'm gathering all the information together, and I can provide an open version alongside with this PR.
Yeah, that would be great. Some descriptive doc so that people can understand and then come to read through the APIs to have better understanding. Thanks. Any other comments or feedbacks? Or you guys need more time?
Yes, clearly, Jin.
Yeah,
we can have a follow-up if you want.
Yes, of course. We will give time to people to read this. Yeah. Okay, thanks, Marianne. This is discussing for the bare metal Tor extension discussing. Before we finish, wanted to ask the community if you would like to raise anything for the next of the future discussings. Okay, if you do have ideas, if you do wanna propose the topic, please let me know. Then thanks, Marianne, for driving today's discussing. Yeah, thanks everyone for attending.
Thank you.
Okay, bye.
Thanks, bye.
Bye.